Alright guys, been a while since I did a video. I've changed a few of my processes. For starters, I now use, I think I might have mentioned this and I went away from it, but now I'm going back to it. I drilled pipe threads, 1/8" pipe threads in the muzzle. I got a high pressure carbonator pump. It's like 150 psi, and I was blowing off my hose no matter what I did to keep it on there. The pressure would build up, a little vibration, and slowly come off. So basically exclusively doing 1/8" pipe thread. I drill it out with the drill bit, and then I come back and just put about 3 threads in it with a tap just in the drill, and away we go. So I'm going to get this thrown in the lathe, and then I'll talk to you about some more stuff that I've been changing up. Alright, I have made some changes to my gang tooling. Couple reasons. One, the boring bar I was using, or the tool bar, was pretty large, and it took up a lot of real estate on the boring bar setup. And I wanted to get that kind of shrunk down. And I wasn't a fan of the round shanked tools. I wanted a square shank tool. So Metal sells this. It's level. I don't have to worry about it rocking in there like a round boring bar. I can actually shim it to adjust my height. So I thought that was pretty handy. Really in love with this little cutter so far. No issues, seemed to last good. And plus I got a little bit more room on my gang tool holder. But I switched over to a top-notch insert, and it's got a lot of rake built into it, a lot of positive rake. And that's been cutting threads with no chatter, even the bigger threads and the smaller threads. So been pretty happy with that. Also, since it's square, I can adjust the height with some shim stock if I needed to get it lower or higher. Problem with using like a, I don't know how to say it, like the boring bar style setup like this is if you want to change your height at all, you're kind of SOL. So definitely really like the horizontal or the square stock horizontal flat surface to for my profiling and my threading inserts. Moving forward, my boring bar for my chambering and my crowning, that's still round. They do make holders for them that are square, but I just kept it round. Not a huge issue there. What's so neat about this boring bar that a friend told me about, it will fit inside a 223 Remington case, and it'll do a crown, which is pretty dang impressive. Most boring bars won't do a 223 case, or they won't do a crown. You can't do both. This is solid carbide. I think I got like $500 wrapped up in the bore. The bar is like right $200, and then the inserts, you got to buy like 5 or 10 at a time, and the inserts are like $30 a piece. So not a cheap boring bar to get into, but man, it gives a beautiful cut. No chatter. I'm running 1,000 RPM, 2 thou per rev, and a 10 thousandths pass, and it just cuts it like butter. I have done any changes to this. I'm absolutely in love with having a Morris Taper number 4 holder on my tool post. Mr. Rick, I know you hate Morris Taper number 4s, but if you're listening and watching, you got to get yourself one of these on your TL. So let's get this thing indicated, and then I'll keep on rambling. Alright, a couple changes I've done in the machine is added some lights. I got a light here, it's a waterproof light, and I got another one, if I come up here, right there, shining down so I can see better. I hate working in a dark, dungy area, just frustrating. So all my programs are written so this ends up with the center line of the barrel, so it comes up 8 inches, and then it'll go in, so this is centered on 0, and it stops. I bet I get 2 emails a week on this. This is an interrapid indicator with a long stylus. If you guys are wondering where I get them, Long Island indicator. No, I do not get any commission off of them. I wish I did, but I don't. So we're going to get this thing indicated. Just go in and out, set my angle first. Once my angle is set, I'll do my run out. I'll do that off camera and then come in back and show you how nice it's indicated. Alright, this one doesn't have a lot of twist to it. It's a 4-groove barrel and a really slow twist, so I can't pick up the lands as I go. So what I'm going to do is just rotate it here. This chuck system pivots over here. So we indicate it up and down to get no run out here. And then we come out and we adjust our angular run out here. So I already did that and life is good. So now we got the barrel perfectly level within 1,000. So I'm going to swap this out with the 1/2 indicator or the 1/2,000th indicator and make sure we're still running true with that. And we're going to do that clear up into the lands, right where the lands are going to sit. And the reason being is we want everything to go off of that point, because we're going to go in there with the drill bit, drill it, and then we're going to pre-bore it. So, and then the reamer, we're going to use a rigid reamer that I built, and we're going to go and ream it so everything's off of where the lands of the bullet are going to sit. So everything's perfectly concentric with them lands. So here's our BR case, right? A little bench rest case. We're just going to hold it up here. The lands are going to sit about right there where the bullet engages. We're just going to go like that. So now we got a mark that gives us a pretty rough idea of where our lands are. So when we indicate where the lands are, we know that when we drill, bore, and rigid ream, everything's going to be perfectly concentric to where the bullet's sitting. So we're bouncing good. We're just probably 2/10 high on one spot. That one's good. All right, we gotta adjust that one just a freckle. Now we're bouncing perfect on all of them. So now we're angularly perfect. So the barrel's bore is sitting perfectly concentric to the machine. And now where our lands are going to be cut, the bore is perfectly concentric to the machine. So angularly and radially concentric. Now we can start our machining operations. So when I set up my gang tooling over here, you can assign it different offsets in the computer for different tasks. Well, one of the offsets that got set up is off the face of my chuck, both in the Z and in the X. So if I tell the computer that this thing's 1.240 away, it'll come in here and it'll just barely touch it. So I'm going to do a 10,000 skim pass to clean this up, and then it'll start cutting the operations, and it'll just shift everything over that inch 0.230. So I'm going to go ahead and push play in the computer. I'll keep the coolant down to a minimum so you guys can watch everything happens as it transpires. Alright, I'm going to do everything kind of slow so I can explain what's going on. First operation is going to be a facing pass. So here's the facing cut I was going to tell you about. So now everything's inch 230 thousandths away from the chuck. It's going to come back out, and then it's going to start doing its roughing passes. Give it a little bit more coolant. Move you over here. So that area right there was for the recoil lug. And this is going to be a chamfer for the threads to start. Then it's going to go to the back and work front. There's the relief for the recoil lug. Now it's going to go over and do a finishing pass. Going to take off the Z. You see a little mark right there. I'm going to cut that down just a little bit. As it cuts, them threads expand. So I'm going to do about 1.5 thou off that on a finishing pass, just so the threads, when you cut them, they expand into spec. So this is the last part of the finishing pass. It'll go over and down. Alright, so that's the tenon is cut now. We'll speed this up. Now it's going to start its threading. I got it on 5% rapid. Comes out 1/2 inch over. Everything's good. We'll speed it up. So I have my thread cut to a certain depth, and then that should be perfect, but I always start off larger and then hand fit them. So the thread probably won't screw on in the beginning, or the action won't. But when I can always adjust it deeper if need be. You can see how nice that positive rake cutter cuts compared to some of the other cutters I've used. No chatter anymore. Makes a beautiful peck. I do 15 passes. And we should be good. I'm going to stop it right there and test fit it. Alright, you can see we got a little relief here. The last Defiance actions I did, the recoil lugs were pinned. And I was able to leave a longer shoulder right here for the recoil lug to slide onto. There's 7 PRCs, but this one's integrated. It's all one piece. So I had to recut the threads. I did that off camera. But the nice thing about CNC, it just keeps on going over the top of them. It's like it never happened. But you can see everything's going on smooth. We get to the end. No play. Good thread fit. And we are all the way bottomed out. So next thing we're going to do is take off this action. And I'm going to start my drilling cycle. And we're going to pre-drill the chamber. Okay? And when we pre-drill the chamber, we're going to leave a little bit of meat so we can come back with a boring bar. So let's start that. Alright, we're going to do a drilling cycle here. And this drilling cycle is going to leave a little bit of meat in there. It takes 1/2 thousandths peck. And then we're going to come back and clean it up with our boring bar. If we just did a drilling cycle like this, the drill bit's just going to follow the hole and it never gets it perfectly on center. One side of the flute cuts more than the other. So when we come back through with a boring bar, it cuts everything perfectly true to the spindle, so the reamer has no choice but to follow the hole that the boring bar makes. This should be the last peck here. And we'll come back with the boring bar and finish it off. Alright, that's that. She's drilled. So now we can start our boring process. So now you're going to see this little boring bar work that I'm falling in love with. It's been a game changer for me. You take 10,000ths a pass. And the nice thing about a boring bar, it makes a hole true to the spindle of the machine. Meaning a drill bit's going to walk, even a reamer's going to walk. If the hole is off center, it's hard to keep it true with the bore. So what we're going to do is we're going to use this boring bar. It's going to make the chamber perfect, but we're going to leave about 8,000ths on each side of the wall for the reamer to eat. And then after we do that, we're going to come back with a rigid reamer that can't flex and bore the hole. Floating reamers are nice, but I have found that they're extremely susceptible, and this goes for all different types, to chatter. And since I have switched over to rigid reaming, I don't have any issues with chatter anymore. My chambers are extremely tight, and my finishes are just beautiful. So we'll let this go. Right now it's cutting the bolt recess, and then it'll cut a little chamfer on there so we don't have to worry about scratching cases. Just kind of highlighting here the finish that thing gives. It does a beautiful job. That chamfer looks big, but we got to take some stuff out of there with the reamer. So I'm going to get the reamer set up, and we're going to chamber this rifle. So I use a grizzly rod to test my pilot fit, and we're going to go all the way in to make sure it fits. And this is a 2361. If I go any bigger, it's too tight. For you guys that do use floating reamers, and you're struggling with chatter, the tighter the pilot, the better. It's not the end-all be-all. But if you switch over to rigid reaming like I have, you don't have to worry about it. So let's get that rigid reamer set up. So a new tool and product that I'm going to be offering is this gizmo right here. I'm coining it the Omni-Adjustable Rigid Reamer Holder. So there's been a lot of talk on forums and this, that, and the other thing about rigid reaming. And I feel I have the operation perfected, at least for gunsmiths on our level. The biggest issue we have with rigid reaming is getting our reamer perfectly in line with the bore. If we're low, meaning too far down or too high, the reamer can turn into a boring bar. If we're too far front or back, it can turn into a boring bar. And then, if the reamer is not perfectly straight with the bore, we can make an enlarged chamber. So when I call this the Omni-Adjustable, I mean I can adjust it any way I need necessary to get zero runout on the reamer. When I say zero runout on the reamer, what do I mean by that? So what I mean is I put an indicator on the back of the reamer and the front of the pilot. And remember, we indicated the barrel's bore to an indicator. So everything's perfectly centered with the bore of the rifle to the spindle. And then we did all our machine work, right? So everything's true to the bore of the rifle now. All the threads, our counter bore, and everything. So now with this jig, this indicating jig that I built, I can now clamp it to a barrel and go around the reamer and indicate the reamer end perfectly to the chamber. Now why did I end up doing this? Well, I was struggling with chatter using the JGS style reamer holders. I thought, well, maybe it's the JGS, so I got a Soma reamer holder, and that chattered. And I talked to other guys. I've had no less than 10 people ask me how I'm chambering on a Haas TL1 without getting chatter. Lo and behold, chatter showed up in my shop. It happened on a 300 blackout. And after fighting with it for a good day and a half, I cobbled up a rigid reamer holder that solved the problem. And since then, I've been perfecting my process around a rigid reamer holder. And this is basically the one I'm bringing to the market. So that's enough rambling about the Omni-Adjustable rigid reamer holder. Let's get the reamer swapped out and get it indicated so we can get this rifle chambered. So this system's built around an ER25 collet. As you can see, an ER32 collet would be too big and it hit against the side of the indicator. These are holes that are adjusted so I can adjust the different lengths of reamers. With this bar, I've done everything as short as a 300 blackout up to a 300 PRC. So it pretty much covers the gamut. So now we're going to indicate, and how I do this is I just go this way to this way, okay? And I get it so we're front and back. So I go 0 here just to get us close. You got some travel. So I start on the back end. Adjust it, and then I go to the front end. So we're 2,000ths and 2,000ths, so I just come over here and adjust this to 1. We split the difference. Go back here. Zero to 0. So now this front one is at 1,000, so we'll adjust that. To move it over. So we got, go over here to 0, come this side to 1. We got to move it my way. So I made the reamer holder to use the same tools, and we're just going to push this reamer on the back and loosen this one a little bit to point that reamer towards us. Okay, just like so. It's at 0 now. So we go here. 0. I went a little too far. Cinch it back up. Loosen this a little bit. Okay, there's half. Half. Okay, we're good there. Now we got to get our height right. So if we're good here on 0 or half, and we're good to here on a half, we'll adjust this down to get a half. So we'll just take this, loosen this guy, tighten this one up. Okay, now we're barely moving on that aspect. So we'll start here, go to 0. To 0. Now this one's reading high. We got to go up with it. So we got to take this jacking screw and go up. So now I have everything indicated perfectly concentric to the machine. You can see this is a 10th indicator. Got 0, 0, 0, 0, 0, 0, 0. And back to 0. So now that we've got everything dialed in concentric, in my machine on the computer I made this its 0 position or its home position. So everything's concentric. So now I need to set my Z space, and just because I got a CNC machine, you guys would do the same thing on a manual machine. You go in, you take a measurement of where you're going to start cutting. You zero out your Z on your digital readout, and then you know where you're at and how deep you got to go. So I'm going to Z face measure on this one. Offset, tool, Z face measure. So now the lathe knows that it's going to start cutting there. I got it set up in the computer how deep it's got to go. And now we just got to let it do its cuts. Start this reaming process. So it's going to go in to where we told it to start. It's going to ream a 1/2 inch. And it's going to come out and start doing its pecking process. It's coming out. Turn the little coolant on. Now I turn my high pressure coolant on. It's going to go in and start cutting. And rigid reaming, this, if it makes any noise, it's going to be right where them 6 flutes come into contact with the chamber. And the reason being, we have it perfectly in line, but one of them flutes might be grabbing deeper than the next. So what happens is that flute will kind of vibrate until they all come into contact, and then they start cutting. Sometimes they'll make a little noise, sometimes they won't. I found if we keep our RPM fairly slow in the first process, it'll straighten itself out within 20, 30 thousandths. And then it just goes on to cutting like life is normal. So this one already started cutting. It isn't making no noise, so life is good. It sounds like air. Once we get about 5 more seconds, it'll made its first 1/2 inch of cut. Then it's going to go back and start its in and out. So now it's going to do its chambering process. It's just going to keep going in and out until we get to the depth we want. Once it gets to the depth we want, I shut it off while the reamer is still in the hole, remove the reamer, take our measurements, and then carry on after we make our adjustment to make it deeper. So I'm making a mess. I'm going to shut this off and come back to you when it's done. Alright, we're coming up. We got one more peck left. And then we should be able to take our measurements. It's going to come out and in. It's probably going to get my camera all dirty. Okay. So the final peck goes in. And then it stops. The reason I go in and stop, that completely eliminates any chance of the chamber getting scratched. So there it is. The reamer's still in the hole. We can reset it, handle jog, and we're just going to back out with our Z. And we should have a pretty chamber, but we got to check our headspace. Alright, so measuring it, we got 7 thousandths left to go. 7 just barely fits. So I'm going to go 9 thousandths. That'll give it a thousandths for crush and a thousandths for headspace. And then we should be done chambering this thing. So I'll adjust our work offset in the computer and run our final step of the program. Alright, I got everything set in the computer to take a 9 thousandths cut. Once it takes that 9 thousandths peck, it's just going to stop. So we're going to go 25% rapid. Cycle start. I'll slowly close this off. Get some fluid going. Whoa, too much. It ain't going to take much. 9 thousandths isn't a lot. You'll see it dwell and then it'll just stop. And this last cut, I do extremely slow so we get a good finish. There we are. So now it's cut. Life is good. Let's check to see if we got our head spaced. Alright, checking the headspace, the action snug. Put the round in here. Free, no issues. Okay. Now, got a piece of tape ready to go. It's about 2/1000 of an inch for this piece of tape. Put it on the back. Hopefully it's got enough sticky left in it. And go in here. And no go on the tape. So we have a perfectly Headspace rifle to 2/1000 of an inch. He did send me a piece of factory brass he told me to try. Let's see if that goes. Free as can be. Alrighty. Headspaced it on the first shot. No chatter with the rigid reamer holder. The next thing I'll do is do our chamber runout inspection. Alright, our chamber inspection. We're up in the lands where we indicated. Come back. We have absolutely no runout in the lands. Each one of these marks right here are 1/4 of a human hair, okay? The human hair is around 1.5 to 2/1000. Each mark here is 1/2 thousandths, okay? So let's stop this here. Just so you can see I'm not doing any funny business. I'm going to take this out. And we're going to put an honest to goodness 10th indicator in it. A 10th indicator is 1/20th of a human hair. So each one of them marks are 1/20th of a human hair. I'm going to put it on there so it touches. And you can see we're touching. And we have no run out on a 10th indicator. So that chamber is as perfect as they get front to back. The finish is perfect. No run out. And that's, my friends, why I use a rigid reamer holder. Anyways, thanks for watching. I know this one's going to be long. Thanks for following along. And check back with us. And as always, God bless.